we need to prove the following. Okay, so first let us do one thing. We are going to consider alpha minus beta to be equivalent to A. Then beta minus gamma to be equivalent to B, and gamma minus alpha to be equivalent to C, such that if we take the sum of A, B and C, A plus B plus C, we'll see immediately that they all sum up to 0. So we have alpha minus beta added to beta minus gamma added to gamma minus alpha. So they all sum up to give us 0. So here we have immediately obtained a condition that means A plus B plus C equals to 0. Okay, let's label this as number 1. Now we can rewrite our given identity on the left hand side as, so we have sine of beta minus gamma. So beta minus gamma, that's going to be B, added to sine of gamma minus alpha, so that's going to be C, added to sine alpha minus beta, so that's A, added to 4 times sine B over 2, sine multiplied to sine C over 2 multiplied to sine A over 2. Okay, so now what we'll do, we will start by first combining. Let's do one thing, and let's rewrite this expression as, now what we'll do, first we are going to combine sine A with sine B. There's a standard formula for that. So we have 2 times sine of the angle A plus B over 2 multiplied to cosine of the angle A minus B divided by 2. And then we have the remaining terms. We have sine C plus 4 times sine A over 2. And now we are going to change A plus B over 2. So since we can use the condition here, since we already considered that A plus B plus C equals to 0, so this would imply that A plus B, that's going to be equals to negative C. Furthermore, we can divide both sides with 2. That's going to give us A plus B over 2 equals to negative C over 2. Now what we do, we take sine on both sides. That's going to give us sine of A plus B over 2. That is going to be equals to sine of negative C over 2. But we know that sine is an odd function. So sine of negative C over 2 is going to be the same as negative sine C over 2. Meaning here we are saying that sine of A plus B over 2, that's the same as negative sine C over 2 provided A plus B plus C equals to 0. Okay, now we can rewrite our expression as 2 times. So in place of sine A plus B over 2, we can replace with it sine C over 2 multiplied to cosine of A minus B over 2. Then added to, now here we have sine C. We have the half angle formula. We know that sine of theta, that's given by 2 times sine theta over 2 multiplied to cosine of theta over 2. So sine C can be also expressed as 2 times sine C over 2 multiplied to cosine of C over 2 added to the term. So now we can take sine C over 2 as the common factor from the first and the second term. So let's do one thing. Let's take 2 sine C over 2 as the common factor. We're going to consider the second term first. So this is going to leave us with cosine of C over 2. And the first term leaves us with cosine of A minus B over 2. Fine. Added to 4 times sine A over 2, sine B over 2, and sine C over 2. Fine. Now, in the next step, what we'll do, we're going to combine these two cosine function. But before doing that, we're going to change this angle C over 2 to A and B. So again, we're going to use the fact that since A plus B plus C equals to 0, we say A plus B equals to negative C, or we can say A plus B over 2, that will be equals to negative C over 2. Okay, now we're going to take the cosine function on both sides. So cosine of A plus B over 2, that's going to be equals to cosine of negative C over 2. But luckily for us, cosine is an even function, so this is going to give us simply cosine of C over 2. We'll get a positive value. So we will replace cosine of C over 2 with cosine of A plus B over 2. Okay, so we will get 2 multiplied to sine c over 2 multiplied to, we have cosine of a plus b over 2 minus cosine of the angle a minus b over 2. And we have the remaining terms. Now we are ready to combine the two cosine function. So here we're going to use the fact that cosine of c minus cosine of d, that's equals to negative 2 times sine of c plus d over 2 multiplied to sine of c minus d over 2. So here we can assume a plus b over 2 to be c and a minus b over 2 to be d. Okay. Now let us further do the combination. So we get 2 sine c over 2 multiplied to negative 2 times. So we get sine of, now what is c plus d? So c plus d means a plus b over 2 added to a minus b over 2. That's going to give us positive a, and we have division by 2. So we get sine a over 2 multiplied to sine of, now we need c minus d over 2. So that's going to give us b over 2. And we have the remaining terms, 4 times sine of a over 2 times sine of b over 2 times sine of c over 2. Now here 2 times negative 2, that's going to give us positive 4. So negative 4. We have negative 4 times sine a over 2 times sine b over 2 times sine c over 2. This gets added to 4 times sine a over 2 times sine b over 2 times sine c over 2. And they are going to cancel out and leaves us with 0, which is the right hand side. So we have successfully verified our problem. So we can say thus the left hand side equals to the right hand side. Hence